And we'll go on to the last talk in the session, which is Carlos Esperjel. And Carlos, you can share your slides now. And he's going to talk about the Lunar Ore Reserve Standards laws. So over to you, Carlos, and thank you for being here.
Thanks a lot, Clive.
Go ahead.
Perfect. Excellent. Well, thanks, Clive, a lot for the invitation, and good morning, everyone. So my name is Carlos Esperjel, and I'm the Space Resources Utilization Lead for iSpace. And today I will be happy to talk to you about LORs. First, I'm going to do it a bit different. I'm going to share with you a real terrestrial mining story.
Carlos, can I jump in?
Space exploration mining companies, and then I'll give you a bit of an update.
You're kind of garbled. Can you stop your video? And maybe that would help your bandwidth.
Let me see if it is that a bit better? Okay, excellent.
Yes, it is.
All right. Again, I would like to share with you a real story from the mining industry, and then a fictitious story from some fictitious space mining companies, and then I'll give you a bit of an update on LORs. Please let me know if you cannot hear me again. All right. So I'll start with the real story of the mining industry. And as many of you might know, I come from the mining industry, and there is a famous real story called the BRIEX scandal, and I'll share that with you, and I'll share why it's important. So this started in 1989 with the creation of a company called BRIEX Minerals in Canada. And their business model was on gold exploration, and they found a very interesting site in Indonesia called Busang. Now, in 1994, they started an exploration campaign or activities. And now in the mining industry, one of the most important activities is drilling. And when we drill, we get something called the core samples or drill core samples, where we hope to find the content, distribution, value, content of, in this case, gold. Now, BRIEX Minerals, they pretty much started reporting that they found anything from 80 million to 200 million ounces of reserves. Vocabulary is very important, right? They say reserves, which is huge. This is like one of the biggest gold mines in the world. Now, of course, their shares went from cents to like lots of dollars. Now, of course, a lot of people invested on it. But then what happened is that in their actual drill core samples, they found no gold, but they needed to keep the shares high. So what they did is they used an old technique in the mining industry called salting. So what they did is that they actually grabbed real particles of gold and they put it into the samples. So back then there were no standards. So the independent auditors really had no base to compare if what was the veracity or the validity of the results. Now, everyone thought this was a huge mining gold mine, right? So in 1996, the government of Indonesia, they got really interested in the deposit. Of course, there's a bit of corruption in there. And they are like, you know what, BRIEX, your exploration permit is not valid, so we're going to revoke it. We're going to give it back to you, but we take 40% of the stakes, and we're going to give 50% to another mining Canadian company called Freeport. And BRIEX kept 45. Then what happened is, of course, the government of Indonesia and Freeport, they wanted to check the data, right? So once they want to look at the data, oh no, it happens an accidental fire where all the sample records were destroyed in Indonesia. And of course, really quickly, the government of Indonesia and Freeport, they start some new drilling. And what happens is that in the drill core, there were no, they found no gold, right? So they reported that the samples were tampered, there were no resources. And something else that happened is that the head of geology or the director of geology actually apparently jumped from an helicopter, or he was jumped. And then pretty much in 1998, this was the biggest mining scandal or salting in the history of the mining industry. And of course, at that moment, the mining industry and government, they were like, we need a change. We need to move forward. So with this, pretty much this is how the standards for the mining industry started or were created. So the NI 43101 in Canada was created, which is an instrument and lives in the Ontario Securities Commission. And it was created from the BRIEX scandal, of course, and it's pretty much a guide for mining companies and exploration companies and to protect investors. So one of the main points is to protect investors. Now, pretty much what they say is that any company that wants to be listed in Canada has to abide to the NI 43101, and they need to follow the guidelines for estimation and reporting of exploration results, resources, and reserves. And one very important point is that a qualified person, which with 5 years of experience at least, has to sign off the report and will be legally liable. But most important, there has to be, of course, transparency, consistency, and reportability. That's the intention of the standards. And this is how standards were created. And now other standards were created after that. So the first one was the NI 43 from Canada. Then JORC, which is maybe the most famous or the one that is being used the most on Earth, and that lives in Australia. Then the overarching CRISCO, those are the main standards for mining. For oil and gas, we have the PRMS, and for the United Nations also have their own. Now, you might be asking yourself, why are they different standards for mining and for oil and gas? Now, the answer is simple. That's because mining has very different geology to oil and gas. At the same time, the techniques and the technologies for exploration, for extraction, for processing, and the markets are very different in mining and oil and gas. So in a similar manner, for space resources, the geology will be very probably different, and we still don't know completely. And for sure, the technology for exploration and the techniques for exploration, extraction, and processing will be very different. And the markets will be different. And this is the reason why we need our own space resources standards. Now, this doesn't mean that we need to start from scratch, of course. All right, so how does this transfer to space resources? Now, I'm going to share with you now fictitious story of a couple of space exploration companies. Now, let's look at Exploration Company A, which is founded, let's say, in 2020, and they're based their business model on neutron spectrometer data from NASA, where they think there could be H2O in the poles. Now, they raise some money and they send an orbiter on the poles, right? Now, in this case, they do not have a permit to operate under any nation. And they start reporting very encouraging results that they found anything from 10 to 20 billion tons of H2O reserves, right? Of course, they want their shares to go high as well. Now, because it's remote sensing, we're going to have digital data. But what happens with these companies is that they do not find the results that they were expecting. But of course, they are running low in money and they need their shares to go up. So they decide to use the old technique of salting. And salting digital data will be slightly easier. And some of the data is available. Okay, let's look at now mining company B. So this is Exploration Company B. Same is another company. It's founded in 2020. They have a similar business model. They look at NASA hydrogen data. They think there could be water on the poles or water ice. They raise some money and they send a rover with a drill to drill at 1 meter in depth. Now, they do request a permit to operate under Nation B, so they do the right thing. And they do report realistic results. They say they found anything from 1 million to 10 million tons of potential resources. Now, they actually have their data properly stored, it's available, and it's transparent, so they do the right thing. Okay, what would happen if we have no ISRU or space resources standards? Let's look at the first company, Exploration Company A. Let's remember they send an orbiter, they find no data, and they sold the data. However, everyone thinks that they found H2O on the moon. So in this case, in this story, in 2025, their Nation A gives them a permit and they take 40% of the stake, and another company takes 50% of the stake. So in this case, they start doing some due diligence, and accidentally there's a fire. So the actuals exactly. So there's a fire and all the data is destroyed, right? So of course, nation A and private company A decide to send an orbiter to try to explore again. But what happens? They find no hydrogen on those regions that they thought they found it. So in 2030, that's going to be your biggest space mining salting in history. And let's hope no one has to jump out of an helicopter in 2030, right? And future funding will be jeopardized. But most important, in 2030, we're going to create the space resources standards, right? And my point here is that we can learn from history from 1996. We can start working on standards now, and we need to establish best practice now. And this is how the Lunar or reserve standards were started in 2018, or LORS 101, with a number of supporters. Now, LORS is being designed to provide the first framework and guidelines for private companies, space agencies, and other entities that would like to explore and use space resources, not only on the moon, but planets, asteroids, in a clear and responsible manner for scientific and commercial entities, for sales and non-sales. So LORS includes 3 classification frameworks. I will share one with you really quick. And a glossary of definitions. I was looking at definitions just before. That's really good. We all need to agree with definitions. And compliance recommendations in ESG, environmental, social, and governance. Antonino was speaking about that before. And guidelines for transparent, consistent, and comparable reporting. Now, very important, LORS is based on existing standards. So we are basing it on JORC, actually, on the NI. We're working with them. And so we're not starting from scratch. But most important, LORS has to be independent, inclusive, collaborative, and a living document. So really quick, I'm gonna share with you one classification system, which we call it the CS1, geological resources. So on the right-hand side, you have geological certainty. At the bottom, you have really low geological certainty, and at the top, you have really high geological certainty. How do we raise geological certainty? We do it through exploration. Now, in exploration, we have prospecting and ground truth exploration. Prospecting is mainly done through remote sensing, like an orbiter, so lower resolution. Now, we also have sub-activities like surface exploration targets and in situ exploration targets. In situ is going subsurface. Now, through these activities, now we can start reporting our exploration results. Lower resolution is speculative regions. And through exploration, we go up all the way to measured resources. This is where the mining industry starts operating, only here. Now, there's something called the geological discovery test line. So if you have not done in situ exploration, then you cannot claim discovery. So that's undiscovered resources. Once you start doing in situ exploration, now you can claim discovered resources. Now, looking at the 2 companies before, Company Exploration A with the orbiter, in reality, they were there. But they were claiming reserves. They said that they had 10 billion, 20 billion reserves. In reality, they were speculative regions. Now, Company B, that sent a rover with a drill, they were doing inferred resources, something similar to Viper. Now, let's remember that reserves is actually measured resources that are economically and technically extractable. But that's another conversation for the future. Now, I just would like to mention something here. Like, I'm really happy and I really support Clive's initiatives on doing this international exploration campaign. And as you guys can see, to go from speculative regions all the way to reserves, there's a lot of work that we need to do, and we need to do it together. So I'm pretty happy that this group exists and that we're starting to work on that. All right, so the next steps for LORS, sorry, I'm taking a bit longer, is LORS has to be independent, inclusive, collaborative, and a living document. So far, those are the institutes or the entities working on LORS. However, we are thinking of sending LORS to ISO, because once LORS is ISO, it's truly independent, inclusive, collaborative, and a living document. It has to be international. Sorry for the delay, and thanks a lot. And I wait for your questions.
All right, thank you very much, Carlos.